All right, we're going to go ahead and evaluate these numbers, 81 to the 1 half, 81 to the 1/4, and so on. So they have fractional exponents here, a little tricky to think about. And the first one here, 81 to the 1 half, is equal to 9. And it's easier to think of this kind of in a reverse way, that instead of 81 to the 1 half is 9, think instead that 9 squared equals 81. That's the way we're a little bit more accustomed to looking at these numbers. And so in the next one here, 81 to the 1/4, uh, what we're trying to do is think of what to the fourth power makes 81. So in the last one here was 9 squared. And then the question mark in this one is what to the fourth power makes 81, and that would be 3. So in this case, this is equal to 3. All right, and the next one, what to the fifth power makes 32? And after a little bit of time, you might come to the conclusion that that would be 2. And so in order to evaluate these by hand without the use of a calculator, you have to kind of turn the information around and think of it in a more traditional way here, where you have a whole number exponent. And in the next case, what to the second power makes 64? And that would be 8. And then the last one, what to the third power, what to the third power makes 64? And I put 3 in the wrong spot there. That should be question mark, which of course is 4. All right, so in order to evaluate these by hand, you have to kind of think of it in the reverse way. Now, to further add to some of the confusion that these can cause, 81 to the 1 half, that is the same as, write it like this, the square root of 81. So square root looks good, but 81 to the 1 half, the 1 half we can do some exponent rules with. So this is more functional. However, this is cosmetically more appealing. In the next case, 81 to the 1/4 is the same as the fourth root. And so to say that it's not the same size root, it's a different size. Here we can see the difference between these two problems. What number times itself 4 times as opposed to 2 will produce our value 81. And so we refer to that as the fourth root, and the 4 goes there to signify that. In the next case, then, this would be the fifth root, 32, and then the fifth goes right up here like the 4. Now, the first one didn't have the 2. You could see, well, I could put the 4 right there. We can put the 5 right there. The first one doesn't have one, and that's because square root is the most common one. So it's just sort of implied that there would be a 2 here. Now, you don't have to write it. If it's anything different, like 4 and 5, you do have to write it to show people that it's not the square root. It's a more uncommon one. And then just to finish this up here, this would be 64. And this would be, square root of 64 and cube root 64 as such. So those are kind of how to do these when the answer to the amount is a whole number. I've got another category here I'm going to call harder, and that is that the answer to these is not a whole number. It's not going to come out nice and cleanly. So we need a little bit better of a way to address these, especially if we're being asked to do them by hand. And so in the first case, 32, what we're going to do, we're going to keep the half, and then 32 is a little too tricky to think about. And so we're going to do a substitution. So 32 is the same as 2 to the fifth. That was discussed up here. 32 is equivalent. And so what we're going to do is we're going to replace 32 with 2 to the fifth and simplify using our exponent rules. In this case, we have a power of 5, and then on the outside, power of a half. And in that situation, we multiply. And so this would come out as 2 to the half of 5 is 2.5 power. In the next case, we're going to do a similar trick here. 81 to the 1/8 is not a whole number. And so we're going to replace 81 with, we could either do 9 squared, but better yet, we can simplify it one step further and instead call it 3 to the fourth. Both would be an okay step to take. However, 3 to the fourth more commonly works out better. And 3 to the fourth is equivalent to 81. Same thing, power to power, we're going to multiply these. 3 to the 4/8, or if you want to reduce that, 3 to the 0.5. And then the last one, 64. Now you could call that 8 squared, but we can do one better. Let's call that 4 cubed. And this is simplified to 4 to the 3/4. We could have done even one step better than that. So it would be okay to end as 4, if you want to call it 0.75. We could have instead called this 2, and that would be to the 6th power. So 2 to the 6th is also 64. And we had a choice to make here. And I went with the 4 just because it came to me a little quicker. However, we could have also stuck with a 2 to the 6th, and that may be dependent on the problem or how much effort you really want to put into reducing some of these numbers down. So this would be then 2 to the 6/4 or 2 to the 1.5. And which one is better? That's maybe case dependent. Uh, Generally speaking, the lower the number, the lower the base. Like this 2 is a little lower than 4, of course. This one is overall ends up being more useful more often. So if you think about it, try to reduce as far as possible with these substitution steps.